Welcome back to Learning with us here at MPB. I'm Ms. Killen. We're going to dive into some more Algebra 1. We are now on Unit 6, and our Unit 6 is going to be Introduction to Quadratic Functions. For this first lesson, we're going to set the foundation. These quadratic functions in real-world scenario, I can recognize key features of a quadratic function and interpret key features of a quadratic function in real-world scenarios. We are looking at standards IF4 and CED3. So this is a new function that we've not done yet, so let's go ahead and get started and see what we've got. All right, the first thing I want us to do is look at some vocabulary. We are looking at this quadratic function, which is a little bit different than the linear that we just learned about. The way that our quadratic equation is graphed is called a parabola. It's a U-shaped, which I think I've talked about that a little bit, but it is a U-shape, which is the parabola. We're also going to learn how to do some things on the calculator. So we're going to look at that stat button, and we're also going to look at the constant rate of change. We're going to remember about those linear functions, and then this new general equation for our quadratic function is ax squared plus bx plus c. So let's go ahead and dive on in and see what we've got. So the first thing I want to do is I want to review some linear functions. I want to make sure that we remember what we've learned, so when we get into those quadratics, it's not a lot of, well, I don't remember, or what's she talking about. So let's look at this. It says, let's review linear functions first. If you are biking down the street at a constant rate of speed, a table can be made to model this scenario that shows your miles traveled versus your time. So we have time in hours, which would be our input, and then we have distance traveled, which would be our output. So if I wanted to graph this, let's go ahead and graph this. So as on your notes page, go ahead and look at that X and Y axis, and let's label some things. I'm going to have one, let's make it a different color so it'll be a little bit easier to see. So I've got 1, 2, 3, 4, 5, 6, and we are going to call this my hours. Always wanting to make sure that we are labeling our axis, and then we're going to label our y-axis, which is going to be our miles. So I'm going to have my miles on my y-axis. Now I'm going to label them by twos. So let's say 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Now, if we looked back, or you look back on your notes page to where we see that graph, it says 1 hour, 4 miles, 2 hours, 8 miles, 3 to 12, 4 to 16. So let's go ahead and put those points on your graph. I'm going to do it on the board. You go ahead and label yours on your notes page, and let's see what we get. So I've got 1 hour, I have 4 miles, 2 hours, 8, 3 hours, 12, 4, 16. Then what do you think it would be for my 5th hour? I'm going to say, let me say 18. Let's just try that. Now, Miss Killen, are you sure? I don't know. Let's see. First of all, I need to see that this is going to be some type of linear function. So this linear function can be written as d equals, and then I know that I start at 0, 0, and every time I go to a new point, I'm going up 4 miles and over 1 hour. So I could say 4x. Now, our distance to time is my 4x. So then, did I correctly plot for my 5th hour? Let's go and see. So I had up 4 over 1 was my first point. Up 4 over 1 was my second point. Up 4 over 1 third. Up 4 over 1 fourth. Up, I didn't do it correctly. It should have been at my 520. So that was a good catch. That was a good catch. So it should be, there is, so if I graph this with a line, it would be a linear straight line. So when we see these linear equations, we are looking at a constant rate of change. I am going an exact amount rising, an exact amount running to get to that next point and to that next point. It's almost like clockwork, so to speak. But now we're going to look at something a little bit different when we talk about these quadratic equations. So let's look. It says, look at the following. Royal throws a stone into the creek below. From the cliff where he is standing to the water's surface is 400 feet. Royal wants to know if his stone falls at a constant speed. Royal asks Scott to record the fall of his stone. After the stone fell, Royal makes the table to show the data recorded. Okay, so at 0 seconds, his rock or his stone is in his hand at 400 feet above the water. At 1 second, it is falling, second, still falling, third, and so on. So do I see a constant rate of this stone falling? Is there a constant rate at which it's falling to the water? I don't see it, but let's see. Let's do the math. So if I take 400 and subtract that 383.9, I get a difference of 16.1. I get 16.1. Then if I look at the difference from my first second to my second second, I get a difference of 48.3. Then if I look at the difference from my second second to my third second, I get a difference of 80.5. And then if I look at the difference from my last 2 seconds, I get 112.7. Well, there's no constant anything there except it's falling to the water. But maybe there's a difference in the difference. Let's look. If I take 48.3 and subtract 16.1 from it, I get this. I get 32.2. If I take 80.5 and subtract 48.3 from it, I get 32.2. If I take 112.7 and subtract 80.5 from it, I get 32.2. I am seeing the only thing constant about this change is that I am changing constantly. My changes are a constant, but it's not changing constantly at that same rate. So where we learn that our linear equations has a constant rate every time, 4 over, 5 over, 6 over, 7 over. That's with my linear. Now with my quadratic, I have a different amount that I'm changing. So that's what we wanted to make sure that we could see. What do we see about this rate of change? It's not constant. It's not constant. So if I wanted to graph something like this, it might look something similar to that. It might look something similar. So what I want to do is I want to be able to get an equation. If my problem just gives me data, I need to make an equation for that. So let's see how we could possibly do that with our calculator. So everybody go ahead and grab your calculators and let's see how we're going to do this. So let's learn how to enter the table and write an equation from that list. So we're making a list. First thing you're going to do is you're going to go to stat. Everybody look on your calculator and see where stat is. Stat is going to be right beside these arrows. Once you go to stat, you're going to press number 1. You're going to make that list. In your L1, you're going to put all of your X values. In your L2, which is your list 2, you're going to put all your Y values. You're going to, after you enter all of those values, you're going to press stat again, and you're going to scroll to the right to where it says calc, C-A-L-C. When you see that, you're going to press or scroll all the way down to number 5, which is going to be your quadratic regression. You're going to arrow all the way down and press enter to where it calculates. So now that we see what our different rules or our different steps are, let's go to the calculator online so I can show you and you can do it along with me. So let's look. So I'm going to press my calculator skill, and I'm going to make it so we can all see what I got. All right, so now it told me that I wanted to hit stat. I want to hit number 1, and then let's put those different points in that they gave us for Royal and his stone. So we had 0, we had 1, 2, 3, and we had 4. Now I'm going to scroll right over here to my L2, and now I'm going to put my height from the top of the cliff. So I've got 400, enter, 383.9, enter, 335.6, enter, 255.1, enter, and 142.4, enter. So I have all 4 of my points. So now I'm going to go back to my stat button, scrolling right to calc, and then going down or hitting the number 5. My list 1 is my x's, my list 2 is my y's, my frequency, we're not worried about the frequency. So I'm going down to where my calculator says calculate, and let's calculate. Now, it gives me y equals ax squared plus bx plus c. That is my quadratic equation. Then it tells me what my a variable equals, and then it tells me what my c variable equals. So let's see how we can put those on paper. So let's go back to right here, and let's see. So I had ax squared plus bx plus c. It told me that a equaled negative 16.1. It told me b equaled 0, and c equaled 400. Now, using the quadratic formula, I'm going to plug in my numbers to my exact variables and come up with my equation. So let's see what that looks like. So I've got negative 16x squared, anything times 0, 0, plus my 400. That is how I make my quadratic formula from just data points. From just data points. Let's say that it didn't give us where we start at 0. Maybe it just gave us the middle points. That's okay. We could still use those middle points of the quadratic, plug it in stat, and it would still give us the same quadratic equation. Good job. All right, so now it says let's enter these on Desmos and see a graph of our data. So we are going to take this equation right here and plug it into Desmos. So I'm going to hit my Desmos button, and let's plug in negative 16.1x squared plus 400. Oh, Miss Killen, I don't see. Remember going to the right side and pressing my minus, and I can pull it down. I can always pull down with my different mouse tools. So this is what my quadratic would look like if I graphed it. My y-intercept is 400, and then when I come back down here to my x, here would be my x-intercept. So I've taken negative 16.1 x squared plus 400, and I've graphed it. I've gotten my y-intercept, which is 0, 400, and I've gotten my x-intercept, which is 4.98445, comma 0. So let's see what questions they're asking us about this specifically. So it says, we looked at Royal's data graph. About how long does it take for the stone to hit the water? Now, remember, when we have the water, and here was the cliff, At 400 feet is where Royal was. We said that the water would have been at 0. So how long did it take for that stone to reach? That would be our x-intercept. So what did we say our x-intercept was? Yes, it was now, that's really difficult to use if I'm having to make sense of exactly what that point is being interpreted as. So what I'm going to do, if we remember our approximate, remember? So it's going to take approximately 5 seconds. Ms. Killen, why did you say 5 seconds? It was 4.9844 and some more change. Well, if you remember, this number right here is going to make that 4 round up 1. So I can say it's approximately going to take 5 seconds for when Royal releases that stone and it hits the water. So that's how we're using this quadratics, and we're using our approximately symbol. Good questions. All right. What can we say are our key features? Well, we said what our y-intercept was 0, 400, and then approximately 5, 0 would be our x-intercept. Good job. All right, the quadratic function can be said to have 2 solutions. This is where the parabola crosses or touches the x-axis. So my solutions, sometimes called 0, is where the value of the y, where the parabola crosses that x-axis. So where we saw approximately 5, 0, my y variable is 0. Or it could have been, let's say, 12.737, 0. My y value is 0. That's why it's called the zeros. It's also called my roots. That's the root of it. So you'll hear it as zeros, you'll hear it as solutions, and you'll call them roots sometimes, just depending on what the problem is that you're answering. So it also says that my x-intercepts is where the parabola crosses the x-axis. Again, showing that that y value is 0 and that x value is going to have some type of number. So those are definitely 2 key parts of that function graph that we need to make sure that we're looking at. Let's try one together. What are the zeros of this quadratic equation in the graph? Well, it's already graphed for us, but what do we see? I see that my graph is continuous. It goes on and on and on. But I also see that it dips down below my x-axis. But at this x-axis, it is crossing it at 3, 0, and it is crossing it at 7, 0. So when it asked me for my zeros, I could say that it was 3 and 7. So those would be my possible solutions or my possible zeros, depending on what my question is. So we got to make sure that we are looking at these graphs and we are getting all that information that they can give us. I've always told you, make sure you study and analyze those graphs, because you can get more information from these graphs than you can from a lot of things about the problem. So we always want to make sure that we're looking at these graphs. Now we want to remember, the rate of change will be different with quadratics than they are in linear equations. And remembering the steps of putting the list of data into our calculator so we can generate an equation. Quadratics are graphed with a curvy line called a parabola that looks something like this or like this, depending on what the graph is. And it also says zeros are the y value of our x-intercepts. I am so glad that you came to work with us and to learn with us here at MPB. I am Ms. Killen. Have a great day.